we have Mike Cavanaugh with us today, and as many of you know, Mike is the president of the FECORE group, and I disclosed a lot of the information a couple weeks ago about what had happened at Lake Balaton, and we had some limited success, nothing like what we were hoping for, but we had some kind of major malfunctions where we had a crystal shatter on the collimator lens of our laser, which kind of threw a wrench in the works, and of course the weather was bad, and the lake was half frozen. It was just bad conditions overall. So fortunately, Mike then, when everybody left, Mike then went back to the Netherlands, and first thing you did, Mike, was what? You modified the mount, right?
Yeah, the main problem that we were we were facing in Hungary, especially when nightfall came, with the limited visibility that we had, we couldn't see any landmarks because it was the weather was so bad. We had no idea where we were actually pointing the laser at. So we worked our way around that by placing a powerful laser on the third floor, and then waiting for the target location guys to see that laser, and then we would have an estimate on where to point the actual laser to, and then we would find that laser. But that was a time-consuming process, and that was a pain in the ass to do, so to speak. So especially with those conditions. So what I did when I got back to the Netherlands is I cut the mount in half. It was almost 5 meters in length, and now it's a little under 3 meters. And I changed both the horizontal and the vertical pitch axis from normal threads to fine threads to save at least the resolution. And before we had 1/1000th of a degree resolution, and now we have 100,000ths of a degree resolution. So we lost a zero, and that's okay. But the main thing that I did, and I worked for 3 weeks on that, was creating an automated GPS targeting system. And what that basically is you set up the mount, you put in your orientation, your angle towards the azimuth, and then your GPS location, and then you target the laser to a short distance where you know the GPS location from. And then you input those two GPS locations and the final destination target GPS location. And then you press enter, and then the mount steers itself to that location, to that orientation. And that was what we tested yesterday. Yesterday at the lake here in the Netherlands, we set up the mount, and we shot the blue laser to a relative short distance across the lake, 21.27 kilometers. And instead of 6 days trying to find the beam, we did it in 5 minutes. And that was pretty awesome. We then went over to another location that was actually 7 kilometers more down the line. And there we had the same ease. It was about 10 minutes, and then we found the beam. It was about 100 meters off its supposed destination, and with a little adjustments of the mount itself, we got it to hit our face. And then we set up the camera at the second location in the water. The tripod was in the water, and we measured the camera height was about 85 centimeters above the water. And I think we're looking at the pictures now.
Yeah, we are.
And the conditions were absolutely perfect. There was no wind, absolutely none. The lake was a complete mirror. You can count the stars in the lake reflection, and that was also visible with the beam itself, because the entire length to the horizon, to where the limit of your eye stops seeing that reflection on the water, to where it hit the beach where we stood, there was a complete straight line, and you can see it in these pictures also. It was an awesome sight.
Yeah, it was incredible, because the lake being such a perfect mirror, and you could see that reflection coming all the way across the lake, right to your point of view, which of course would eliminate and completely annihilate any idea of any refraction, right? And
Yeah.
what they did this time, Jaron, and this is something that if you remember I suggested a long time ago as the way we should be doing this, and this is 100% valid, because the way that you did it this time kind of eliminates the need for having an extremely low beam divergence. And the reason for that is because instead of trying to get that beam all the way across, 20, 30, 40, 50 kilometers, whatever, and have it have a low enough beam divergence that you can hit like a reflective surface and see it that way, instead what you do is you just take almost any laser or bright light source and you take the optics back to the laser. In other words, what they were doing out here is they had a P900 that the laser, they could see the laser, and then basically they just kind of would zoom the P900 back and forth, and you could see the laser still, even with the P900 all the way zoomed back, and it was hitting them. But then they could zoom right up to the source of that, which again completely annihilates any claim of anybody saying, oh, that's just refracted beam, right? Because you're looking, you have kind of a meeting in the middle between where the optics are going and where the beam is going, and any way you look at it, guys, it's flat. So
yeah, you can't see through water. You can't see through that hump of water.
No.
You would never see the light on the other side of water. It's going to reflect up and away. You're not going to see it. So yeah, I mean, that goes back, Bob, to when we did the first 4-mile experiment across Monterey Bay, and the second day we went back, and it was your idea to have it take the optics to the light, which is exactly the way we did it, and what proved that if the camera can zoom in and see the light that's being shined on a backboard that's I think we got it as low as 1 inch or 2 inches above the water line, then there's no hump of water in between us. So that completely defeats the whole idea of the way their spherical Earth would work.
Yeah,
exactly. I would like to see this beam from the side just to know that it's not refracting. And frankly, this wouldn't affect I don't think the notion of flat Earth or globe Earth to me, because, okay, what I'm getting at is if you look at the Stephen Hawking laser beam across a body of water video, you'll see this happen. Or if you look at the laser beam through a fish tank full of sugar water video, you'll see this happen where the light refracts like at a pretty low angle down towards the ground or down towards the water in this case, and then bounces off the ground or bounces off the water. And then once it gets back up to the elevation where the beam started, it's almost like it goes perfectly back on the path that it was on originally, because it's going up, and out of that highest density gradient. But I'm just wondering, did you guys have any side view of that laser, or would it be possible to get such a side view just to make sure that the beam is indeed going straight or parallel with the water all the way across?
No, the problem with lasers is you cannot see them from the side. It could be shining on a 350 meters on your right, and you won't see it. You will only see it when the source of the light is hitting your face.
Or if there's some kind of particulates in the air.
Exactly.
Right?
Yeah. Exactly.
Yeah.
Which of course,
and then that would affect the beam, right?
Bingo.
Yeah. Sean, here's why I think that if you went out and actually saw it, when we were doing the two tests that both failed, because I was trying to do the opposite. I was trying not to take the optics, but to take the laser to the 4-mile distance. You knew immediately when you accidentally hit, for instance, the road or anything or a bush, because as soon as you do, the light turns into a million splotches. It looks like snow. There was people walking between the two locations at the 4-mile spot, and when they were walking back, they were saying well, how come who's shooting a laser from that side? It's we said nobody, and they said we kept seeing a laser come from that way back this way. Because what was happening is we were hitting the road. We had gone too low, and it hit the road, and then it would just it created a disaster. So it's not like you would be able to see if you were looking and it was refracting or hitting the water. What would happen after a laser hits the water turns the laser into a mess. I mean,
right.
It's not
so you'd be able to tell from where the camera's at here if there was that much interruption or interference on the beam.
And if you're saying if they're talking about maybe it's so, I guess what you're saying is if we were on a ball and they lowered it and it hit the water, that you're saying the light would then reflect up, and what you would be seeing from the other location would be that reflected light up. Is that kind of what you're saying?
Well, no, I mean, I'm saying this knowing that the Earth is flat, and like if you think about curved water and a beam acting like it's going over a mirror like we see, that's not possible. So I don't think that's good evidence for a globe at all.
Right.
But just knowing that the Earth is flat and see being able to see what light does when it goes that, because even though there's no wind and probably low evaporation because it's nighttime, there's still going to be a fairly thick atmosphere above the water.
Yeah,
and
I agree.
It's almost like you would expect the laser to do what we always see it do over long distance. How far was this again?
The farthest distance was 28.73 kilometers.
Wow.
Yep.
That's awesome.
Mike, what was the at that distance at 28K, what was the calculated drop that you had figured out?
I'm not sure about the drop, but I do know with those elevation heights, we were supposed to be hidden behind 40 meters.
40 meters, yeah. That's about what I figured, yeah.
Yep. And
so either the laser's shining through 40 meters of water, or there's 40 meters difference between you and the laser and the laser, right? Yeah.
The laser does not penetrate the water, because as soon as you shoot it at the water, it just reflects back up.
Yeah.
Right. And yeah, I mean, I don't think that would have any bearing on the experiment, even if the laser was sort of skipping across the water, other than totally messing up the beam. But yeah, that's amazing though, because you would expect to see the beam raise at that distance relative to the ground, and it's obviously not raising at all, just diverging a little.
Yeah.
Yep. Okay. Well, and the thing that I want to point out, and guys, for those of you that are watching this, not only live but after live in the Flat Earth chat, you will see a certain individual in the chat, or several certain individuals in the chat. We call these people trolls, because all they do is sit there and call into question things and never do any research themselves. One guy in particular I am addressing here is a guy named Jeff Resnick in the chat, and of course he wants to know why we should accept this information from them, third-party observers or anything like that. And of course they're going to do stuff like that. They're going to say stuff like, oh, well, anybody could have just, that laser could have been 3 feet away, whatever. Well, I'll tell you what, Jeff Resnick, what you need to do is you need to go out and do it yourself, instead of being an idiot armchair quarterback and sitting here calling us and our results fake. But do you guys ever do it? Do the ball earthers ever do that? No, they don't. All they do is sit there and hammer on us and tell us, that we're lying about our results. And, it just makes you look like the jerks you really are. So I'm sorry, but go do the experiment yourself. You know why you don't? I'll tell you why you don't, because you're going to come up with exactly the same results. And those results are flat. And that's why not one ball earther has ever done a laser experiment to our knowledge, unless, of course, you want to take the Stephen Hawking nonsense that's been debunked time and time again as gospel. But just wanted to say that. And go ahead, Mike. I'm sorry I had to get on my horse there for a minute.
Well, we are not doing this to satisfy anyone but our members themselves, of course. And my own curiosity, I built this machine because I like doing this. And the results show that it's flat, and that is awesome. So, and if people don't accept it, well, that's their problem. I don't care.
Yeah.
That's not who I'm doing this for.
Exactly.
And if they want to do it themselves, then they can use my equipment while I'm there and do it themselves, record everything, and get the same result. But I'm going to count on that never happening.
Yeah, no, it never will. It never will, and nor would they ever come forward, because they know full well that it's going to come back with exactly the same result. So this is something.
That's why
Oh, go ahead, Jerry.
I was going to say the test that they do is fly to Honolulu on the equinox and show that the sun sets at 270, and they call that proof of the ball earth.
Well, this is it for me. It's like, extraordinary claims require extraordinary evidence. So I'm still looking for the extraordinary evidence that shows that if it's true that they claim that we're on a ball Earth with a hot iron core, etc., spinning at 1,000 miles an hour, flying through space at X knows what speeds, in some sort of a reference frame of velocity and forces. Well, I want to see the evidence. So show me the experiments that prove these things as factual, that are unfalsifiable.
Great job on that yesterday, and you did a fabulous job. And obviously, you're going to even continue to try and make these shots further. Can you tell everybody a little bit about what happened with the crystal on the original one out at Lake Balaton, and why you weren't using that, and what's going on with that?
Yeah, the primary laser, with the one with the collimator lenses that we were initially supposed to use, that had a somewhat of a design flaw by the designer itself. It had a thermal security relay in it for as soon as it dropped below 5 degrees Celsius, that it would turn off automatically. And when we were shooting the laser on the first night, it turned off sometimes. So Mina, the laserist, thought that it was not warm enough, but it was actually a cable that was not connected correctly. So because she thought the laser itself was too cold because of the weather conditions, she started to heat the laser, and then because of that heat, she cracked the crystal in front of the laser, and that wrecked that laser. And it was not something that you can repair while you're there. You have to order that crystal from probably from Japan, I guess. And then it has to be installed. You have to pay for it, of course, so it takes money. So we're still waiting on that laser to be repaired, and as soon as it is repaired, we're considering optimizing it to it now is a green laser with an output power of 3 watts, and we want to try and rebuild it to an output power of 10 watts, and with better collimation and in a blue color, because blue, I think, is more easy and better visible as soon as it starts hitting your face.
Yeah, and it has a lower beam divergence just by its nature, because of the higher wavelength, or the shorter wavelength, yeah. I should say. Yeah.
Yeah, sure. Yeah. So that is in the works. This experiment that I did yesterday was actually only to test if the GPS targeting system software was working. And now we got to the 28.7 kilometers. There's still 2 points on the lake that we can get 40 kilometers from, and that is something that we're going to try and get in the coming weeks. The good thing is that I live at the lake itself, so as soon as the conditions started getting as they were last night, I just pack up my mount, throw it in the back of my van, and drive to the location and do it. So that puts some ease into it. But as soon as that laser, the primary laser, is fixed, then we're going to attempt 88 kilometers on the Waddenzee here in the Netherlands, and that's actually a sea that is connected to the ocean, so it has tides. And that way we are able to do it in the same method that we were aiming for in Hungary, dragging the beam along the ice from the shortest distance all the way across. And that's what I'm going to try and do at that experiment. Because of the low tides, you can actually walk where the water is supposed to be, get that beam on a board or something behind you, and then walk out. And as soon as the tides come back in, you step on the land, you stop your laser mount, and you know exactly where your beam is. And then as soon as the tides go out again, you step onto the water and you go more distance. And that is something that is coming up very soon, I hope.
Yeah, that's awesome. That'll be great. Yeah, I'm sure everybody will look forward to seeing that. But yeah, it was really exciting yesterday, guys. I got to tell you, because we were kind of running it internally for the group on Skype, and we recorded all the hits and everything. So it's all recorded, and I think they're in the process of putting those video clips, as well as some of the stills that I was showing earlier, up for general distribution to the public, along again with the methodologies, the maps, the locations, the height of the laser. All this stuff is going to be out there, so that all you trolls that completely complain about us not doing it right or whatever, well, again, we would
Yeah.
love to see you do it, which none
Yeah,
of you
yeah.
have ever done.
The project documentation file itself, we've been getting complaints, mostly by trolls, that we did not provide sufficient information about the experiment itself. Well, those things take time. You do not compile, especially 6 days of data in a couple weeks, especially if you're not doing it full time. Everybody in this group in FECORE has a day job, and we're basically doing this in our spare time. So that's plus the fact that we're in I think 10 or 12 different countries, has a lot of coordination issues with that. So these things take time. The complete documentation file from Balaton experiment is almost done. Sander is completing the file right now, and what we did yesterday, it was basically only an experiment to test the GPS targeting system, but we did get those hits, and those data and video files and pictures will also be included in that same documentation file, because we initially started it out as a Balaton laser experiment, and now I basically renamed the entire experiment to the laser experiment, because it's an ongoing experiment. We started in Hungary and we're now in the Netherlands, and as soon as we get the maximum results here, maybe some other, we were supposed to go to Dubai also, so it's an ongoing process, and we got a lot of data to recover.
Yes, absolutely. So yeah, that's beautiful, Mike. And like I said, those of us watching yesterday were actually thrilled. And when you're not trying to track that laser beam all the way across and hit a little bitty target from 20, 30 kilometers away, it makes it a lot easier when you can take the optics directly to it. And I think that'll be pretty much the methodology that we use from here on out.